Anterberg's limits, which is shrinkage limit, plastic limit, and liquid limit. Shrinkage limit is the moisture content in which the transition from solid to semi-solid takes place. Semi-state means that the fine-grained soil is softer than being the solid state, but it's still harder than in plastic state. And plastic state and the plastic limit is where the moisture content at which it goes from semi-solid to plastic state. And plastic state is kind of solid, but you can still remold without crumbling. Liquid limit is when it goes from plastic to liquid state. So liquid acts like a liquid and is diluted. Ways to find liquid limit is through the percussion cup method. So in this method, you put the soil paste in the cup, and then you cut a groove of certain size, and you want to drop the cup from like 10 millimeters height, and then you want to see the amount of blows it takes to close the distance of 12.5 millimeters along the bottom of the groove. And the blow should be between 15 to 35, and to analytically you would graph the moisture content and the blow number. The blow number would be on a semi-log, and you will find the moisture content at n equals 25, and that will be your liquid. It is through the Falcon test. It seems to give a more consistent result than the percussion test, and it's simpler to use. But here, the process includes that you have a cone of apex angle of 30 degrees and a weight of 0.78 newtons, and you have to find the right moisture content that will allow 20-minute penetration in 5 seconds. And later you will have to take the moisture content and the cone penetration and graph them on a semi-log scale. And you have to find liquid limit at where moisture content at 20 millimeters. And you can use the flow index formula on the side to find this. Is the moisture content at which value of the soil ceases to change at a certain point. And this is because as moisture decreases, the soil shrinks, but at a certain time it stops changing the value. And plasticity index is the difference between liquid limit and plastic limit. And as you can see over here, different plasticity index can indicate different plasticity. Sugar classification is called the United States Department of Agriculture, and it is very dependent on the classification chart. And this chart is only used for soil that passes through number 10 sieve that are particles smaller than 2.0 millimeters. And you have to find the intersection of different sand, slate, and clay percentages to find what it is. And if the particles are greater than number 10 sieve, then we have to make adjustments accordingly. I learned about the Hw2 system, where the soils are mainly divided into 7 primary groups, A1 through A7, and based on they can also be divided into subgroups such as A1A, A1B, for example. And A1 through A3 are granular soils, and A4 through A7 are fine-grained soils. And based on whether they're fine-grained or granular, you use different tables to find out what they are. The idea is that all the criteria in one column have to get satisfied in order to classify the soil, and you also need to calculate group index. And for different type of groups, you may have different requirements. For example, but one rule of GI is that if the calculation came out negative, you have to it's the USCS classification system, which is one of the most widely used systems to classify soil. And I learned that the number 4 sieve is the threshold between gravel and sand. And based on the table, you have to first determine whether it's coarse-grained or fine-grained soil. And coarse-grained soil is if you have 50% more retained on number 200. And after you decide whether it's coarse or fine, you can tell gravel and sand percent based on how many passes the number 4 sieve. 100 minus what percent is finer than number 40 tells you percent gravel, and between the percentage between what passes through 200 and 4 will give you percent sand. And after you do that, you can decide the percent fines, which is what passes through number 200, and you can calculate the necessary parameters in order for fine-grained soil, which uses the plastic chart for classification. And the plasticity chart requires liquid limit and plasticity index, and most soil should be below U line. Above A are slit soils, and clays are usually between A and U. Real empirical relationships to find maximum dry unit weight and optimum moisture content for cohesiveless and cohesive soils, and different tests such as vibroflocation, dynamic compaction, and blasting can be used in the field for compaction as well.